as part of the backup, Igneous provides a product called DataProtect. So DataProtect is a modern network-attached storage backup solution. We install on a VM, and we can use as a source any NFS network-attached storage or SMB. We do have API integration with several vendors, but again, we could work with any NFS gateway. And our DataProtect product manages your backups and can write to any of the major cloud providers in any tier, or any private S3 or any private NFS for your destination. And Igneous was designed from the beginning to be extremely scalable, handle trillions of files and hundreds of petabytes of data. It was also designed to help you manage cost and be cloud ready for organizations that want to move that direction or already had a cloud footprint. And we are available on the AWS and Azure marketplace. We were designed for true scale-out data protection. So any scale. Our customers in general start at 100 terabytes, but most of them are much more than that. So we were designed for hundreds of terabytes and millions of files, all the way to 100 petabytes and trillions of files. And this is all through a single interface. Many organizations, especially large HPC installations, will have multiple NAS systems of varying size and type and file footprint. We're designed so that you can view all of those through one interface. And we'll work with any, go ahead.
Yeah, I was just gonna say, like, this is a good example where we have a case study on our website with Quantum Spatial. They do a lot of like planes flying overhead, and they have a lot of satellite imagery that they download and process. It looks like most HPC workloads where there's a capture from plane, a bunch of processing, and then a workflow automation to go push it off into the cloud. They're an example of a site that moves petabytes of data around on a weekly basis. They also have multiple sites, and so in their 7 sites, you know, their big value is that they can see this through a single pane of glass and manage all locations, all data movement through a single pane of glass. So why don't you talk a little bit more about the capabilities then Adam?
Sure. So we were designed for HPC-level performance, and I'll talk about our specific technologies a little later. But in summary, we don't want to overwhelm your application. HPC is, the performance is critical, if nothing else. So we have user space clients, and we minimize IOPS. We have a custom data structure that we wrote for our file index. We're not based on a Postgres database or any other type of relational database. We are latency aware, as well as having dynamic throttling. What that means is we can monitor latency on primary storage so we don't interfere with user workloads. This plot here shows how we adapt dynamically to user operations. So as those scale up, we scale down. And this is to eliminate impacts to other workloads. You certainly don't want backup slowing down HPC and delaying the time to results.
So, and this is partly what makes cloud usable for us. So Adam just mentioned there's 3 components that we talk about of our infinite index, our adaptive scan, and our IntelliMove, which we'll talk about later, of having the foundational components of what we do to make sure it scales at the scale of the enterprise, or the scale of the environment, or the scale of the organization. But when we started down this path, we said, hey, you know what, cloud is going to be something that is really predominant in the future. And one of those places for backup is, how do I replace what I'm doing today, or how do I implement something that leverages the cloud and do it with the right economics? When you start talking about Glacier Deep Archive, you're talking $12 per terabyte per year. When you talk about Azure Archive Blob Store, you're saying the same thing, and also with Google, but they have their characteristics that can really catch you if you're not conscious of the ways that they charge. And so we've been in this world where we have optimized for the cloud first. It still works going to private S3 and private NFS in the same way, but it is a parallel ingest, a multi-threaded ingest. And then we do a lot of work to make data efficient going into the cloud and being expired from the cloud. And so what does that mean? Well, we take a bunch of small files and we aggregate them together. We take big files and we create multiple chunks, but we create the appropriate size chunk so that when you're writing that data into the cloud, if you were putting 1 billion files in, it'd be around $500. If you did that in native format, you put 1 billion files in, the transaction cost of 1 billion files into Azure Archive Blob Store would be somewhere around $50,000. So these are the things that you have to be really aware of when you're starting to leverage the cloud to make the economics work. And of course, we do all the compression and efficiency associated with putting data in the cloud so that you're trying to get it in the most optimal footprint possible. The other thing we do is we've decoupled expiration from what we'll call compaction or reclamation of data, which means that if you have a retention that you want to set on data, whether it's 30, 60, 90, 180, 5 years, 6 months, whatever it is that we don't actually just go immediately expire that data from the cloud and reclaim that space, because that can get costly also. What we do is we expire data out of the index, and so it's no longer recoverable, and then we run a compaction algorithm on the back end that says when it is cheaper to go reclaim that data and compact that data based on rehydrating it, reading it out, and putting it back in, we will do that. And we'll do it when it's cheaper to go reclaim it than it is to store it in perpetuity. So as a result of that, when we go and meet with folks, the economics that we typically align are how do you evaluate what you're spending today, and how do you work on a TCO that makes sense. And the big part of this is it's pretty customized to everybody that does this, but there's a lot of different components into backup that we don't always think about. There's the easy one, which is if you're on tape and the tape cost, but it's also the amount of data that you're moving. It is the refresh cycles that you go through. It is the efficiency of operations associated with it. When you go to disk, it's probably the Cadillac of backup when you're going disk to disk and using vendor-specific replication. That's great for DR, but you're probably overloading yourself for backup. And then when you go to cloud, it's those things like cost around transactions and cost around storage. So we have this great ability to go dissect all those costs for you and provide you with the TCO before you get started, before you try it out, just to say, hey, is this going to make sense for you?